Good day to everyone. I have posted a few notes in the chat about our meeting room. Just to remind you, so if you read the chat, you will see what you should or should not be doing during the session. We should be starting in a few seconds. It's currently 9:59. Well, it's 10 o'clock now. I want to welcome you to the class. I am not sure if I should give 5 minutes so that other persons could get here. I am currently only seeing about 6 or 7 persons here. And so I'm going to give 5 minutes to see if anybody else shows up. Whoever shows up, we will start in 5 minutes. I hope that those of you who are here saw the notes about calculator, because what we're going to do today, we're going to be working some mathematics questions, just so that you will see, you'll get an idea of what is required. You also to expose you to some of the mathematical things that you will actually have to do as an operator. So it's really application today. Okay, it looks like some people are having trouble getting in. Okay, so I'm still here. If you have any questions, you can ask, but I'm turning off my video and I'm going to answer a few queries in the Kawasa online.
Like it looking like that tired.
All right, good day to everybody. All right, I'm going to start right now. I want to welcome you again to our Saturday class. I trust that you had a good week and that you are safe from COVID-19. I know that throughout the region we are having, we are taking a lot of action to protect ourselves. And I trust that you in the other islands are doing safe. Today we're going to continue with our mathematics for operators, but today's class will be a bit different. I want to first apologize for Mr. Alphonsus Daniel, who started off the math with us, but he's not able to do today's class because of some of what's going on in Grenada. He's very involved. So I want to apologize on his behalf. I hope that we can have a productive class. I want us to focus on two things today. In our last session, Mr. Daniel spent some time looking at some of the mathematical principles that water operators, distribution water operators will require, knowledge that they would require in order to be effective as a distribution water operator. Now, we've done quite a bit of theory, and I thought it would be good today for us to work some questions. So I have selected 10 questions. I think we can do the 10 questions in the hour. The procedure we are going to do, I am going to post the questions. I have them in a presentation. So I'm going to put the question up. I will give you about 1 to 2 minutes to read the question. Then I'm going to shift from the presentation to a whiteboard. And I am going to show how the question should be worked. Now, you can feel free, if you think you can work the question in the 2 minutes, feel free to try, that's fine. What I would advise you to do, the recording will be made available to you sometime after the class. So what I would suggest, okay, is I'm going to post the presentation after the class. I'm going to post it on the Kawasa online platform. So you can go and attempt the questions on your own without looking at what I have done, okay? And when you're done working them, you could compare them because the stuff is being recorded. You could go through the video and compare how you worked it, your attempts to how I worked it, to see, you know, to see if you remembered. That would be a good way of setting things in your permanent memory. So to have some kind of contact with that material after you've gone through the session today. So that's what I would advise. So the presentation will be up, just the questions will be up, and you can look at the video to obtain the answers. So Cook just joined our meeting. Welcome, Cook. So I'm switching here to my PowerPoint presentation. So let me mute my video. So I need you to confirm that you can see. I want to make sure everybody can see the video even before I continue. If you can see, just type yes in the chat, please. I'm giving you 30 seconds. Just type yes in the chat if you can see. All right, wonderful. So I see 2 answers. Okay, I see a few more. I hope that these are representative of the entire group. All right, wonderful. So So we look at water mathematics basically again. Okay, so this is what we are going to do today. That's our objective in essence. We want to work through exam type mathematics questions. So on your level 1 exams, these are some of the questions that you may see. Now, the level 1 exam is not, the amount of math that you're going to see is not going to be very high, okay? So, but what we will cover, what we have covered and what we will continue to cover, will give you a fair understanding of the mathematics so that you should be able to answer the questions that you will be presented with on the day, okay? Also, the second thing we want to do is to apply mathematical concepts in distribution scenarios. So in our previous class, Mr. Daniel went through quite a few mathematical concepts and principles. So we want to see how they apply in distribution as we answer these questions. So we are going to go to the first question. So the first question, records on a pump indicate that it pumped 1,228,400 gallons during the 31 days of May. Calculate the average gallons pumped per day. So that's our question, okay? So from the question, there should be two things that you should see: the amount of water, the total amount of water that was pumped for the month of May, the 31 days of May, and the number of days in which that was pumped, okay? So our answer, the average we want is the average gallons per day, okay? So let's switch to the whiteboard and we are going to look at this calculation. So once again, if you can see my whiteboard, I would like you to type yes. You can see my whiteboard. I would like you to type yes. Okay. So according to what we've been told, total gallons pumped is equal to 1,228,400 gallons. Okay. Now we will ask for the average. Okay. Average is equal to the total divided by the number of items. That's how we do average. Okay. Now, according to our question, what do we know? We know the total gallons pumped, and we know the number of days. Okay, number of days is 31. So that tells us, if we have to apply that to the formula, that tells us we should do 1,228,400 divided by 31. Okay, and that gives us an answer of 39,625.81. Okay, which we can round off to 39,626 gallons. So this is how we would calculate our average. Do I have any questions? Is that clear and simple for everybody? If you can respond in the chat, just type, just give me a thumbs up if that was simple enough for you. Thumbs up. So that's our first question. So I'm actually leaving it there for a bit. So if anybody wants to write, they can write. But okay, but I'm not going to leave it for long. As I said before, the video will be posted and you can see the solution later. Okay, so let's go to the next question. Now, I want to remind, I'm hearing some sound, and I want to remind you that your mic should be muted. Okay, so let's go back to our presentation. All right, so that was our first question. So second question, many times you have to convert from a percentage to a decimal value if you have to do calculations and so on. Okay, so this question, convert 81.67% to decimal form. So that's our question. Okay, so I'm once again going back to our whiteboard. So a fresh whiteboard. So a few things before we do the calculation. Percentage suggests or means, so it implies out of 100. So when you hear the word percentage, it means out of 100. Okay? So when we say 81.67, we are saying 81.67 out of 100. That's what 81.67% means. Now we can write this as a fraction, 81.67 divided by 100. And since that's a fraction like this, this can also mean 81.67 divided by 100. So we can do that calculation, which will give us 0.8167. So this is our answer in decimal form. Okay. So this is how we get our percentage in decimal form. So now we can take that value and actually use that value to do calculations. Any questions so far? But any questions? Do you understand? Just give me a thumbs up in the chat. Okay, so these two first questions were two very simple questions. Okay, I'm happy that most persons understand. So next question. So we're getting closer and closer to application. It says, calculate the pounds per square inch pressure at the bottom of a tank if the water level is 33.11 feet deep. Calculate the pounds per square inch. So pounds per square inch is a measure of pressure. It's one unit that we use to measure pressure. We could also have kilopascals, which is another unit. Another unit that is used is millimeters of mercury. Some of you may hear millimeters of mercury when you listen to the summary of the weather for your particular area. So let's see how we would work this one. So we go to our nice whiteboard. Okay. Now this is telling us that we have a tank. Okay. Now I'm not really an artist, so don't bother with my drawings. Let's say we have a tank. Okay. And our water level is here. Okay. What happens with substances is that somebody has their mic unmuted and I'm getting some feedback. Thank you very much. Somebody has their mic unmuted. Can you mute your mic, please? I'm still hearing. Okay, so what happened? The weight of the water is acting on the bottom of the tank. So it's applying pressure to the bottom of the tank. As the depth of the water increases, the amount of pressure applied to the bottom of the tank actually increases. And it increases by a specific amount for every foot of depth, or every foot of the height of water, every foot of the vertical height. Okay? So the figure that we use, we write it one of two ways. We say that we either have trying to see who is, that's Mr. Gill. Okay. All right, so that's sorted out. All right, so we say that we have, for every 2.31 feet, right? We have 1 psi. So that's one way of looking at it. Let me erase that. Okay. Or another way of looking at it is we have 0.433 psi for every foot. Okay. So as we increase our vertical height, or the depth of the water, as the depth of the water increases, the amount of pressure acting on the bottom of the tank is going to increase by 0.433 psi for every foot of vertical height. Okay, so going back to our question tells us that this height here is 33.11 feet. Okay, so that's the height of the water. Okay, but we know that the pressure is going to increase by 0.433 psi for every foot of vertical height, or every foot of depth of water. So then, using this, we can calculate what the pressure will be, what the pressure at the bottom of the tank will be in psi. Okay, so our calculation will look something like this, and I'm going to show it using both figures. Okay, the first one, if we were to use the first constant, we would see that depth in feet, okay, over 2.31 feet per psi. Now, what happens with these? What happens with these units when we do our multiplication? Okay, if we have feet over feet per psi, we can also write this as feet multiplied by psi over feet. Okay, so what ends up happening is this cancels that, and we are left with PSI. So let's see our calculation there. Okay, so that tells us we can do 33.11 over 2.31. That should give us an answer of 14.3 PSI. Of course, that's a rounded figure. Okay. Alternatively, we can do depth multiplied by 0.433. Okay, so that's depth in feet, and that's feet per PSI. Sorry, that's PSI per foot. My error. And if we were to look at what happens there again, we will see that we have feet multiplied by PSI over feet. And we can see that this cancels that, leaving us with only PSI. Okay, so either way, we get the same answer. So is either this or we do 33.11 multiplied by 0.433, and we should get our same answer. Okay, please note that 1 over Note that 1 over 2.31 gives us our 0.433. So this is how we would work a question like that. In order to work this question, we must be aware of this fact. Usually on the exam, you would be presented with a sheet of formulas, so a mathematical sheet that has all the formula that you would need to use in the exam. Okay? This formula sheet will be furnished, you will be furnished with this formula sheet at some point in time so that you can have it to make use of it. Because it will be good to be using the same formulas, the same constants that are being used in the exam for your calculations. One more thing I want to mention about our calculation here is that if, for instance, the depth were given in meters or inches, you would have to do the conversion from meters to feet. I believe a meter is 3.3 feet, somewhere around there, but close to 3 feet. Okay, I think it's 3.3. And if it were in inches, you would have to divide by 12 to convert the inches to feet, because our units must be consistent with the units that are in the formula that we are going to use. So when you are doing your mathematical questions, please pay attention to the units that you are given and the units that are in the formula that you want to use. So I'm switching back to our presentation. Okay, so that was question 3. Question 4 is a question again about percentage. What percentage is 15,325 of 21,611 to the nearest 10th of a percent? Now this question, since we already worked a percentage question, I am going to give you 2 minutes to see if you can answer this question correctly. Once you have calculated, post your answers in the chat. So I'll be waiting for your answers in the chat. So you have 2 minutes. Okay, our 2 minutes is up. I see some good answers and I see some correct answers. Now, some of you may find it strange that I see some good answers and some correct answers. Okay, I want you to pay attention to, if you had 70.9%, you are among those with the correct answer. If you had 71% or 70%, you are among those with a good answer. The correct answer is 70.9. And the reason why this is the correct answer, we are told to do it to the nearest 1/10 of a percent. A 1/10 of a percent is 1/10. So they're asking us to give an answer with at least 1 decimal point in that answer. So rounding off to 71 would not be a correct answer. In any case, in the exam is going to be a multiple choice exam. And you never know if the examiner wants to be difficult, and the examiner may have 71 as a possible answer. But if you chose that, you would not get the correct answer because they're looking for an answer with a decimal place. Also, those of you who rounded to 70, while it shows that you did the correct calculation, rounding off to 70 is not quite right because you get a decimal value that is 0.9. Once the decimal value is 0.5 or above, usually we round up. If the decimal value is below 0.5, we round down. Okay, that's what we usually do. In some instances, some persons use 0.6, but I think 0.5 is the way to go. So once it's 0.5 or above, you round up. And once it's below 0.5, you round down. So that's the rule that we want to follow. So I'm going to go to the next question, but you did very well. It shows me that you understand how to do the calculation, even if you didn't quite get the 0.1% correct, but it still tells me that you understand how to do the calculation. But when you're doing these questions, pay attention to the various things that are asked for in the question. So to the nearest 0.1% is a very important part of that question. So I'm moving to the next question. Solve the proportion 6 to 72 is equal to x to 480. 6 to 72 is equal to x to 480. So I'm going to switch to my whiteboard. Okay. So once we hear the word proportion, this suggests that we are doing ratios. I believe Mr. Daniel touched on ratios last class. Okay. So if we have this value, if we have 6 to 72 is equal to x to 480, it means we can write these as fractions. So we can say 6 over 72 is equal to x over 480. Okay, so we can say that. So now we have an equation that we can work with. Now, if we know anything about equations, we will know that whatever is on the left-hand side is equal to what is on the right-hand side. Okay? So 6 over 72 is equal to x over 480. Now, in order to solve this, we want to change a few things around in the formula. Now, since both sides are equal, we can say if we can multiply both sides by the same thing. So 480, 480, 480. Okay, so since they are the same, both sides are equal. If we multiply each side by the same thing, we have not changed the equation. Okay, because both sides are equal. Now I chose 480 here because we want to get rid of this value underneath. Okay, now since this value is being divided into x, if we multiply everything by 480, it will allow us to cancel this 480 out. Okay, so then we end up with a formula, with an equation that says x is equal to 6 over 72 multiplied by 480. All I did was just switch it around. It's kind of weird to have the x on that side, so I just put the x on the other side and I put everything that was on the left. Like I did a mirror image kind of thing. That's all I did there. So try not to get lost at this point. Okay, so now we have something that we can work with. So we can do the calculation here. 6 into 6, 1, 6 into this, 12. Okay, and then 12 can go into 48. But we have 480, which is 10 times 48. Okay, so 12 can go into this 1 time, and 12 can go into this 40 times. Okay, and that gives us our answer, 40. So now we can say that x is equal to 40. So this is how we would work this question.
Now, ratios are important, especially in disinfection, when we have to, for instance, we change in our fluoride for the water, and we have a piece of equipment called a chlorinator that is pumping chlorine into the water at a specific, well, what we have found, a specific feed rate. Okay. Now, if we change the flow rate and we want to maintain the same amount or concentration of chlorine, then we would have to change the feed rate appropriately. And that is what our next question will look at. So what we have used here to do this simple ratio, we are going to apply these same concepts to a chlorination question. I know we have not done disinfection as yet, but as I said earlier, the idea of the class is to expose us to how we will use some of the mathematical concepts in the distribution system. So I am switching back to my presentation for us to look at the distribution question I just mentioned. Okay, so this was our ratio question, and this is our distribution question. Chlorine is fed at a rate of 25 pounds per day for a flow rate of 7 cubic feet per second. To maintain the same dosage, what adjustment to the, that should be chlorinator, that's an error. What adjustment to the chlorinator should be made when the flow rate is increased to 12 cubic feet per second? So we have 25 pounds per day on our chlorinator. Okay? That's our sitting on our chlorinator. And we feeding that into a flow rate of 7 cubic feet per second. But we have increased our flow rate to 12 cubic feet per second. And we want to maintain the same amount of chlorine. Okay? So let's look at how we would calculate that. Once again, this is a ratio question. So let's load our trusty whiteboard. Okay. So what do we know? Chlorine feed rate is 25 pounds per day. Our flow rate for our water is 7 cubic feet per second. I'm writing the entire thing out so that you can see. Okay, a note here. Once you hear the word cubic before a unit, cubic suggests volume. So once you hear that word, think volume. Just a note so that, because you're going to see cubic things like cubic yards. In addition to cubic feet, you will see things like cubic yards, and we'll use cubic yards when we are dealing with more solid material. For instance, if we dig a trench, or we have to dig a trench, and we want to know how much material we have to put in the trench after we put the pipe, we could calculate the cubic yards of material. Most of the time when we buy solid material like sand, gravel, and things like that, we buy them in yards, cubic yards. Okay, so these, once you hear these things, think volume. Okay, so going back to our question. So we know these two things, and we know we want the new flow rate is 12 cubic feet per second, CFS. Okay, but we don't know what the new chlorine feed rate will be. So we can refer to it as X. So we can say that in the first instance, we had 25 pounds per day to 7 cubic feet per second. Okay, we can say that this is equal to X pounds per day to 12 cubic feet per second. Okay, since this is a ratio, we can write these as fractions. Okay, and we can use some of the same things that we did a while ago. We want to get rid of the 12 to isolate the X, so we multiply both sides by 12. Okay, so now this cancels that, and we are left with our formula. So now we know that X is equal to 25 over 7 multiplied by 12. And this gives us 42.86, which is approximately 43 pounds per day. So this is how we arrive at that calculation. So that's our answer here. So this is what we're going to set our chlorinator to. Do I have any questions? If it makes sense to you, give me a thumbs up in the chat. I'm not seeing responses in the chat. Okay, great. It started coming in. I guess people were writing. All right, great. Wonderful. So once again, let me go back to our little presentation. Okay. All right, so that was our first chlorination question. So we have 3 more to do. We're doing 10 questions. So a solution is 5.8% hypochlorite. Hypochlorite is a chemical substance that is used as a in disinfection. Okay, what we usually refer to, most people loosely refer to as chlorine. Okay, for disinfection, that's one of the forms that it comes in hypochlorite solution. Okay, what is the milligrams per liter of hypochlorite in the solution? Now, to answer that question, we need to go back a bit to some of the things that Mr. Daniel spoke about in his presentation last week. Okay, and when we see terms like milligrams per liter, okay, once you see terms like that, you're thinking of a solution. So it's a liquid. So we're looking at the amount of solid hypochlorite that was dissolved in water, in a certain volume of water, to obtain that solution. Now, what do we know? When we are doing
Sorry,
solution,
but the screen is blank.
yeah, that's a whiteboard.
Okay, thanks.
Yeah. When we are doing solutions, we know that a 1% solution, okay, is 10,000 milligrams per liter. Now, how do we arrive at that 10,000 milligrams? Okay. Usually we said that percentage is out of 100, right? So a 1% solution can be said to be 1 gram per 100 milliliters. Okay? So that is also, so that's 1 out of 100. Now, 1 gram. So let's break that down. 1 gram is the same as 1,000 milligrams. Okay? And 1 milliliter is the same as 1,000. Sorry. It's the same as 1 liter, sorry, is the same as 1,000 milliliters. Okay? So we have so between this 100 here, and this 1,000, we have a factor of 10. Okay? So 1,000 divided by 100 is 10. Okay? So that means we must multiply this by 10 to convert it to liters. Okay? So this will give us 10 grams, okay, in 1,000 milliliters, which can be written as 10 grams in 1 liter. So 10 grams per liter, okay? And this, remembering that, this can be written as 10,000 milligrams per liter. So this is how we arrived at this original figure here. That's how we arrived at that. But in the future, you will not have to go into all of that. I'm just doing it so that you understand how we got to that point on the top. So what you need to remember is this. Once you remember that, 1% is 10,000 milligrams per liter, then you can calculate anything that you need to calculate. Okay? So, how many milligrams will we need for a 5.8% solution? Okay? If we want 5.8%, all we have to do is a multiplication, because it means it will be 5.8 times the amount. Okay? So that means 5.8 multiplied by 10,000, which gives us 58,000 milligrams per liter. Okay? And this is our answer. Any questions, concerns, queries? If this is clear to you, give me a thumbs up in the chat. All right, we're doing good. Okay, so we're going to look at a slightly different, the next few questions will be slightly different from what we have been doing. Okay, so the next question looks at circumference. Okay, and when you think of the word circumference, we're thinking about a circle and we're looking at the distance on the edge of that circle there. So the line that forms the circle, how long is that line in essence? Okay, and we have specific formulas for these. I believe the mathematics book that is in the downloadable resources looks at some of these formulas. In any case, I plan to post the formula sheet that comes with most exams. I plan to post that in the downloadable resource. If it's not already there, I plan to post it so that you will have it available to you. Okay, so let's look at how to calculate. I'm not sure if individuals here remember how to do this from school or from the presentation done by Mr. Daniel. But if we have a circle, okay, I'll attempt to draw a circle. Yeah, okay, my circle looks like a head, but that's fine. Okay, so if we have a circle, to get the circumference, we use the following formula, pi, which is a mathematical constant, multiplied by the diameter. So I'll just put the diameter as d. Okay, so pi, we usually use the value 3.142. Okay, in some places they use 3.14. Some persons, if they're using their calculators, the calculator has the constant stored in it so that you could use it. It will give you all of the decimal places here. Okay, but if you just remember 3.14 or 3.142, you should be fine. Okay, so from our question, we know that our diameter is 75 feet. Okay, so if we have to plug this into our formula, so the diameter, before I go on, the diameter is the distance from one side here. Basically, you splitting your, if you were to split your circle in half, the line that forms here would be your diameter. Now, you would come across this term in distribution when you speak about the pipe diameter. Or if you have a circular tank, a cylindrical tank, sorry, the cylindrical tank will have a diameter, because at the top, if you look down at the cylindrical tank from the sky, you will see a circle. Okay, so that anything that has a circle has a diameter. So this tank is 75 feet in diameter. So then our circumference will be 3.142 multiplied by 75. I'll put the 0 because they gave us 75.0. Okay, and that should give us 235.65, which is approximately equal to 236 feet. Okay, so when we're talking about diameter, again, we are looking at the distance from here, go around the entire circle. So we're looking at that distance. Okay, now you may ask, why would we want to know that distance? Okay, it can be that we want to install something that goes around the tank. Maybe it might be some kind of metal stuff that will be wrapped around the tank. We need to know the circumference for that. It could be a range of other things that we want to install on top of the tank, and we want them separated by a certain distance, or maybe we want them to be separated what we call equidistant. At equidistance, which means the distance between each item must be the same. So we want equal distance between each item. We can use the circumference, find the circumference divided by the number of items, and then we know the distance that we have to place them. And that's just two reasons why we want to find that value. Okay, so this is our answer here, and this is how we work a question like that. So let's move to, if we don't have any questions, let's move to the next question 9. Again, I remind you, if you have any questions, you can ask your questions in the chat and I will respond to them. Okay, so next question. I alluded to this question when we were working a previous question, the question with the cubic feet per second, the flow rate. So a trench is 430 feet long, 4.0 feet wide, and 5.5 feet deep. How many cubic yards of soil are excavated from that trench? So very often in distribution, when you are either installing pipes or making repairs, you would have to dig a trench and do an excavation, okay? Which means you're taking out the soil. Now, if you're doing a new installation, when you take out the soil to lay your pipe, all the soil will not fit back into the trench, okay? Now that's 1, 2. In some instances, the soil that you remove from the trench, you will not be reusing it, okay? Maybe you might want to start, because when we do these topics, you realize that very often when we lay pipe, we depend on the type of pipe as well, but we usually try to avoid putting sharp stones and certain types of particulate in the trench that's in direct contact with the pipe. Especially if this thing is going on the road, you want to have a solid like sand or something that does not have very large particles that will kind of cushion the pipe. So when you finish your repair and traffic resumes on that road, the amount of the pressure from the traffic does not cause one of these these stones or gravel to puncture the pipe, and you end up with a leak, and you have to go and excavate that thing again, and it costs the company in terms of man hours, it costs the company in terms of material, and in terms of money as well. So that's one thing we usually take a precaution on. But when you put the pipe in, say you put in a 24-inch pipe in the soil, in the trench where you have excavated, it means that the volume of pipe, for instance, that soil will not be replaced. So that's why we are doing these kinds of calculations. Also, if you're excavating a trench, you may want to know how many cubic yards of material you're removing, because probably it has to be trucked away. So if you know how many cubic yards of material you're removing, right, then you know how many trucks you will need to carry that away, and you can estimate the cost of that. That you could add that estimate to the estimate, your cost estimation for the little project that you are doing there. So being able to calculate things like that is very valuable. Okay, it contributes to how effective you can be in the field. So mathematics is actually meant for everyday use. Okay, I don't know what, a lot of people have a fear of mathematics, but if you were able to understand these concepts and apply them, you'd be a much better operator. Okay, you'd make significant contributions to your units wherever you're working and to your company. So you would be an asset to your company. And in everyday life as well, you could be doing something at your home where you have to excavate something, and you want to try to figure out how many trips a certain size truck would need to make. So on a personal level, this could also be beneficial. So let's look at how we work this example. Now, I want you to note here that for many of the questions, a process that we have been doing is first consider what we know. That's another way of doing it, known, unknown. So this is another way that we could write out and figure out what we need to know from the question. So from the question, we know length. So I've been doing it, but I haven't been saying explicitly that this is known and unknown. We know length, we know width, we know depth of the trench. Okay? So we know this is 430 feet. We know this is 4.0 feet. We know that this is 5.5 feet. Okay? But we want to know volume in cubic yards. Okay? Now, as we do our calculation, we know that what we have, we say we have what we call a cuboid. So we have a shape, something like that, according to what we've been given. So we know we have a shape like that. We know that that height is 5.5. We know that this is 4, not drawn to scale. Okay, and we know that it is 430. So this is feet, feet, feet. Okay? So since this is a cuboid, our volume will be length by width by height or depth. Okay, so this can also be referred to as height. Okay, so we know that this is 430, this is 4.0, this is 5.5. This gives us a value of 9,460 cubic feet. But what do we want? We want cubic yards. Okay? But what do we also know? We know that 1 yard is equal to 3 feet. Okay? Not the number of people in the yard, but 3 feet. Okay? It's not based on the feet of the people in the yard. Okay? So, but we want cubic yards. So if we raise this to the power of 3, and we raise this to the power of 3, then we'll have 1 cubic yard is equal to 3 by 3 by 3, which gives us 27 cubic feet. Okay, so we know that 1 cubic yard is equal to 27 cubic feet. So what can we do with that information? So we have cubic feet, 9,460, and we want cubic yards. But we know that 27 cubic feet per yard, per cubic yard, sorry. Okay? So what will end up happening is this is going to cancel out that and leave us with cubic yards. So when we divide 27 into this value, we obtain 350.37 cubic yards. And we know how many cubic yards we will have at the end, and we can tell the truck driver, we can know how many trucks we need. We could even know how many barrels, if we know the volume, how many yards a barrel could hold. We could know how many barrel trips we need to make as well. Okay, so this is how we work a question like that. If we are good, let me know in the chat, please. So give me a thumbs up in the chat. If you have any questions, now is the time to ask them. If you do not ask during the class, and after the class you realize you still have not figured out something, then the COASA platform is available for you to ask your questions as well. All right, so wonderful. So I'm getting a lot of yeses. Okay, so let's go back to our sorry, not whiteboard. We go back to our presentation for the final question for today. Okay, so final question, question 10, how many gallons are there in a pipe that is 18 inches in diameter and 216 feet long? So we hear gallons, we think volume, but what shape is that pipe? Okay, so that's our question. So I'm going to go to our whiteboard for us to work. So your screen will look white, but only for a short time. Okay. So what do we know? We've been told that we have a diameter of 18 inches. We've been told that the length of the pipe is 216 feet. Okay. So if we were to visualize what we have, we know we'd have a pipe okay, and we can say that a pipe is a cylinder. So that will give us an idea of what formula we'd need to use for our calculation. So we know that from this point to that point is 216 feet. So that's our length. Okay, and we know that our diameter is 18 inches. So that's an 18-inch pipe. Okay, so I want to point out something here. We also know that our formula, and this is the formula that will be on the sheet. So formula for number of gallons in a pipe will be equal to 0.785 by d squared, and d here stands for diameter, by length, okay, by our conversion factor, which is 7.5 gallons per cubic feet. Okay, somebody is giving me a water sound there. Okay, so this is the formula that we are going to use. Now note, this formula is going to use this conversion to change what we get here, which will be in cubic feet, to gallons. Okay, so this part here is the formula for the formula for calculating the volume of a cylinder. Okay, and this part here converts to gallons. So that's the constant that we use to convert to gallons. Okay, so now that we know that, our unknown here is the number of gallons. Okay. All right, so I want to point out something here. We were given the diameter in inches. Now, I mentioned that earlier, that sometimes you're given your measurements in units that are not consistent with your formula. Our formula here requires feet. Okay? So we must first convert our diameter value. So convert diameter to feet. And we do that by dividing by 12 because we have 12 inches in every foot, which this will give us 1.5 feet. So now that we have made that conversion, we can plug our values into the formula. So 0.785 multiplied by 1.5, right? By 1.5. So that's our diameter square. I put in brackets, so just to point that out, by 216 by 7.5. And when we plug this in, we get 2,861.325, okay, which is approximately equal to 2,861 gallons. And that is our answer. So that's our answer here. Okay. So this is how we calculate the amount of gallons in a pipe. Now, you may ask, where might I want to use this? And I want to say disinfection. Say that you have freshly installed, you did a repair and you had to remove a length of pipe from the distribution system and replace it with a new length of pipe. You will need to disinfect that length of pipe. So you can use these things to do your calculation of how much water is in there and so on and so forth. You can even extend that to more than one length of pipe. So you have a section, you close off valves for a section of the distribution system, and you had some kind of cross-contamination. When we say cross-contamination, we mean that something from the outside of the system is getting in either for a breach. We have a pipe that is broken or so badly corroded that water actually gets into it from the soil. Okay, so we can actually have contamination happening as a result. And maybe we figured that out early enough so that we close off our valves and we have a section of the system, we know what pipes are there. So we could do calculations to know the volume of water that we have to treat and so on and so forth. So that's just a rough idea of how we can use that. Okay? So this is how we work out this volume. Note that that formula will also be on your formula sheet for the exam. So all you have to do is go to it. And it automatically does your conversion for you. It gives you the number of gallons right away. So you don't have to do it as a separate calculation. Okay? I am not sure if we have any questions, but while I wait for your questions or concerns, I want to remind you that we are recording this session and it will be made available to you. I am going to start. In the past, we've been emailing you the links to the video, and I want to start placing a link to the video for the week, in that week. I think we've done it for a few, so we will continue that, so that it, in addition to getting your email link, look out for the link in the on the COASA online platform, so you could get everything in one place. Okay, do I have any questions? Okay, 0.785. Okay, let me erase a section here so I can write. Okay, I erased the diagram because I'm assuming that persons can actually do without the diagram. Okay, the 0.785. Normally what we do with our formula for a cylinder, okay, normally we have pi over 2 squared. Not pi, r, sorry, which is our radius. And the radius is half of the diameter of the circle. Usually we have the formula like that. Pi multiplied by r over 2 squared. Not r over 2, d over 2, sorry. Okay. So what happens when we square that? We end up with pi d squared over 4. Okay. So we can also write this as pi over 4 multiplied by d squared. So that value we have there, the 0.785, that value is actually that. So that's how we arrived. That's how we arrive at this value. Okay, so I'm glad that has been made clear. Do we have any other questions? Or somebody's asking whether the video will be available by the end of today. I am not usually the one posting the video, but we will try to see if that can happen by the end of today. Okay, we will try. Any other questions? Okay, if there are no other questions for now, I want to remind you that you can still ask questions on the Kawasa online platform. We answer the question, whatever you post there, we answer it within 48 hours. So you will get an answer. I usually try to log in every day. So I'm usually looking at what's there every day to see if persons ask questions. I find that usually when I go there, I don't see any kind of movement. So I don't see questions, I don't see discussions. I don't see much there. I want to remind persons who have not tried the quiz, because I noticed that several persons there are persons who did several attempts. And based on the numbers I'm seeing, everyone has not done it. So I want to remind you. And in speaking about that, I also want to, I know that people have different ways of dealing with course material. Some persons wait until the few days before the exam, and that is when they do most of their work. Okay? Some other persons do not work like that. So whilst I keep reminding you to go and check this out, go and check that out, I bear in mind that people work differently. Okay? And I want to encourage you to do what works for you. Okay? But please know that the platform is available. Okay? It's available so you could ask questions for clarification. It's available so that you can try out the quizzes and the various exercises that are there. I am not sure how many of you were able, since I didn't see any questions, I'm assuming that you were able to work through the math sheets that are on the site on your own quite readily without any issue. Yeah? If you have any issue, the question forum is available so that you could post and answer. Now, we have gone way past the time. I know that we started, I waited for 5 minutes to let everybody come in before I started. It's now 11:25 and I'm going to bring this class to an end. I want to thank you for attending, and I want to say enjoy the rest of your Saturday and be safe. In terms of the coronavirus, the various ministries have, and the World Health Organization have given guidelines for what you should do. I want to encourage you to follow these guidelines so that we can meet again next Saturday and we can have another great class. So all the best, and thank you. Goodbye.